Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 1 to 5 of the January 2017 Geometry Common Core Regents exam. Alright, let's take a look at question number 1. It reads, which equation represents the line that passes through the point -2, 2 and is parallel to y equals 1/2 x plus 8? Okay, so the formula that we're going to be using to generate the equation of the line, let's go ahead and write that down, is the point slope formula. Okay, the point slope form of the equation of a line is given by y minus y1 equals m x minus x1. Okay, now there's something you want to keep in mind concerning parallel lines, the slope of parallel lines. So let's recollect the facts. Recall concerning parallel lines, what do we want to keep in mind? If two lines are parallel, then what? If two lines are parallel, then they have equal slopes. Okay, they have equal slopes. So that's something you want to keep in mind. Okay, alright, so these are the steps that we're going to be using to generate the equation of the line. First of all, we're going to find the slope of the given line. Okay, the line with the given equation. And then next we're going to find the slope of the second line. Okay, I'm going to call it m parallel, the slope of the line parallel to the original line. And then after finding that, using the point and the slope, we're going to write the equation. Okay, so in step 3, we're going to be combining the slope, the point in this formula right here to generate the equation of the line. Okay, let's go ahead and apply all this together in solving this problem. Let's start from the first part. Let's find the slope of the given lines. The line is y equals 1/2 x plus 8. This is in slope-intercept form, which is y equals mx plus b. So if you write the equation of a line in slope-intercept form, the slope is given by what? The slope is the coefficient of the x value. Okay, so m, the slope of the original line, is 1/2. Next, we need to find the slope of the line parallel to this line. Okay, it's indicated here that the line that goes through this point is parallel to this line. So what's that slope? Well, since the two lines are parallel, then what? That follows that the slope of the first line is going to be equal to the slope of the second line. So the slope of the parallel line is going to be 1/2 also. Okay? Alright, now let's go ahead and execute the final step, which is to write the equation. Now if we want to write down the equation, we need the slope, m, we already know is 1/2, m parallel to be specific, and then we have a point, -2, 2. This tells us that x1 is going to be -2 and y1 is going to be 2. So we'll put all these together in the equation that we wrote earlier. Y minus y1 equals mx minus x1. Plug everything in here and solve for y. Okay, so y minus y1 equals m x minus x1. So be careful here. x1 is negative, so we have minus minus 2. Alrighty. Now we are just going to get y isolated if you look at the options that we have here, they're all in slope-intercept form, so we need to get y by itself. First things first, we have to multiply these two signs. Minus times minus, slash and dash is going to be plus. So we have y minus 2 is equal to 1/2 x plus 2. Anytime you multiply the same signs, you always end up with positive. Okay, now next step involves distributing the 1/2 to x and positive 2. Okay, so that gives us y minus 2 equals 1/2 x plus 1/2 times 2. Okay, what is 1/2 of 2? 1/2 of 2 is simply 1. Okay, so this becomes y minus 2 equals 1/2 x plus, and then this divides out, 2 goes here, 1, 2 goes here, 1. You have 1. Final step involves adding 2 to both sides so that y can be isolated. So we have y equals 1/2 x plus 3 as the final answer. Answer to question number 1 is option number 3. Okay, let's take a look at question 2. It reads, in the diagram below, triangle ADE is the image of triangle ABC. Okay, so we have ADE here. This is the image of this other triangle right here, as you can see. How did that happen? Well, after a reflection over the line AC, followed by a dilation of a scale factor AE over AC centered at point A. Question, which statement must be true? Alright, so when you dilate one shape, one geometric figure to get another, what happens? You end up with two figures that are similar. So let's go ahead and write that down. Note, if one triangle is dilated to form another, then the two triangles are similar. Okay, so so what does that mean? Well, there's some conditions that apply when two triangles are similar. One of the facts is that corresponding angles are congruent. Okay, so that implies that so similarity implies that corresponding angles are congruent. Okay, that will be sufficient here. So let's go ahead and list our corresponding angles in this situation here. All right, so corresponding angles here are angle B and angle D are corresponding angles. This was reflected over there. And then angle BAE and so BAE and angle DAE are corresponding angles. Talk about these two right here. And then angle ACB and AED. Okay, angle ACB and angle AED. Alright, talking about these angles down here. These are corresponding angles. Okay, now since they are corresponding angles and these two triangles are similar, what does that mean? It automatically implies that all these listed angles that we have here are congruent. So let's take a look at the pairs of angles we have here. Okay, so angle BAC, so BAC, that's that one right there, and angle AED, are these corresponding angles? The answer is no, they are not corresponding angles. Okay, for BAE, the angle corresponding to BAE is DAE. So these are the corresponding angles that are congruent. So what does that tell us? It tells us that statement number 1 is false. Statement 2, we have two angles here. Angle ABC, angle ABC, and angle ADE. Okay, oh, these are corresponding angles. Okay, angle ABC and angle ADE. When I wrote it here, I just called it angle ABC, I called it angle B. Okay, that's another way. And ADE, I called it angle D. These two are corresponding angles, so they are congruent. So let's write down the remark. Since angle ACB and angle ADE are corresponding angles, and the two triangles are similar. Okay, angle ADE is similar to triangle ADE because of the dilation ABC. Then it automatically follows that the measure of angle angle ABC. Oh wait, I switched this around. This is supposed to be ABC. The measure of angle ABC is equal to the measure of angle ADE. When you dilate figures, the angular measures are preserved. The size of the angles do not change. It's just the size that are dilated. Now, why can't we even take a look at these 3 and 4? The scale factor is AE over AC. There was no indication that 1/2 is the scale factor, so we do not know what the scale factor is. So that's why these two are automatic fails. They are false statements because we do not have the scale factor specified in any part of the question. Okay, so the answer for number 2 is option number 2. All right, let's take a look at question 3. It says that given triangle ABC is congruent to DEF, which statement is not always true? It could be true sometimes, but not always true. All right. Now, what do we know about congruent triangles? Let's go ahead and write down a note, something to note real quick. Concerning congruent triangles, what you want to note is that if two triangles are congruent, then what? If two triangles are congruent, then corresponding angles, sides, the perimeter and area are congruent. Okay, so that's a situation where you have two triangles that are congruent. The side measures are congruent, the perimeter of the two triangles are congruent, also the area of the two triangles are equal to. Okay, actually let me reword this. So let's just say corresponding angles and sides are congruent. Since these are objects, are congruent and the perimeter and area, these are numerical values, and area, the perimeters and areas are equal. Okay, so that's more accurate. So let's go ahead and give ourselves a visual as to what's going on here. So what we're going to do is we're going to go ahead and sketch two congruent triangles. Okay, so we have two triangles. Let's go ahead and label them. We have A, B, C. So A, B, C. So when we are naming the second triangle, we want to follow the same order, okay? So D and A are corresponding angles, so this has to be D. B and E are corresponding angles, so this is E, and this is F. Okay. Now, so the question is, which is not always true? Segment BC and DF. Let's ID those segments. So BC and DF. Well, let's first of all indicate the corresponding ratio of sides. Okay, so this side corresponds to this side. They are congruent. Since these two triangles are congruent, this side right here corresponds to this side. They're congruent, and then this side corresponds to this side. They're congruent. Okay, we know the SSS congruency postulate just indicates that corresponding sides are congruent. So BC, segment BC and segment DF, what do we know about them? They are not corresponding sides, so we cannot conclude that they are always going to be congruent. Okay, if these were equilateral triangles, then that would work. Or if these were the opposite, the sides of an isosceles triangle, then it could work. Okay, so only in special cases that you have a scenario where a triangle sides that are not corresponding are congruent for triangles. Okay, so what do we say here? Since segment BC and DF are not corresponding, since they are not corresponding sides, then they are not always congruent. They are not always congruent. When two triangles are congruent, in order for two sides to be congruent always, they must be corresponding, and that is not the case with option 1. Okay, so this is not true. Let's take a look at the others just to confirm what we wrote here. A and D, check this out. These two angles are corresponding angles, so they are congruent. Okay, C and F are corresponding angles, which means that they are congruent, and then B and E are corresponding angles, which means that they are congruent. So this is true. Areas are equal to, because every measure is the same. So the base and the height for these two are equal. So when you compute 1/2 base times height, you will get the same thing. Perimeter of the two triangles are equal to, because the side lengths are exactly the same. So when you find the sum of the length of the three sides for this triangle and this other triangle, you will end up with exactly the same result. Okay, so the reason that option 1 is false is because these two sides are not corresponding. Alright, let's take a look at question 4. It says, in the diagram below, segment DE, DF, and EF are mid-segments of triangle ABC. Question, the perimeter of the quadrilateral ADEF, this quadrilateral right here, is equivalent to, so what is the area of this quadrilateral right here? That's the question. Okay. Okay, so the first thing that we're going to write down is the theorem concerning the mid-segment of triangles. Okay, so let's write that down real quick. So theorem for mid-segment of triangles. Now, if you have a mid-segment, there's a special relationship between a mid-segment and the third side. Okay, so mid-segments are parallel to and half of the third side. Okay, so third side being the side that does not contain the mid-segment. Okay, so with that in mind, since we're looking for ADEF, we're going to focus on this mid-segment right here and this mid-segment right there. Okay, so based on this theorem, we know that DE is going to be parallel to AF and is going to be half of AC. Okay, and then we also know that AD is going to be parallel to this mid-segment right here, and this mid-segment EF will be half of this third side AB. Okay, so let's go ahead and write down some equations. DE, that mid-segment is half of the third side, is going to be half of AC. And then how about EF? Following the same theorem above, EF, this mid-segment right here is going to be parallel to this side, this segment to this side, and is going to be half of this segment. Okay, so EF is going to be 1/2 of AB. Alrighty, now definition of mid-segments. If these are mid-segments, basically these points practically bisect the sides that they're touching. Okay, so D and F are going to be midpoints. Since this is a mid-segment, this is a mid-segment, this is a mid-segment, these are midpoints. Okay, so since D and F are midpoints, basically where the mid-segments touches the sides, we can write down some equations. We can write down AD is going to be 1/2 of AB. Okay, what are we saying here? We're saying that this side right here is congruent to this side. Okay, and then also if we look at this side AC and this midpoint F, what equation can we write? We can say that AF is equal to 1/2 of what? AC. Okay, so what I've done is I've isolated the lengths of the four sides of this quadrilateral ADEF. We have DE, we have EF, we have AD, and AF. Okay, so what is the perimeter? The perimeter of quadrilateral ADEF is simply the sum of the four sides. So it's basically DE plus EF, DE plus EF plus AD plus AF. Okay, so let's substitute the values using AB and AC. So DE is 1/2 AC plus EF is 1/2 AB. Using these two equations up here, plus AD is 1/2 AB plus AF is 1/2 AC. Using these two equations down here, now we can combine like terms. 1/2 AC plus 1/2 AC is AC, plus 1/2 AB plus 1/2 AB is just AB. So the perimeter is AC plus AB, which is the same thing as, you can write it as AB plus AC since addition commutes, right? AB plus AC. Final answer for question number 4 is option letter number 4. Okay, let's take a look at number 5. It says, in the diagram below, if triangle BE is congruent to triangle CDF and the segment AEFC is drawn, then it could be proven that quadrilateral ABCD is it a rhombus? Is it a rectangle? Is it a parallelogram? Or is it or is it a parallelogram? Okay, so there are different ways to prove that a parallelogram, a quadrilateral is a parallelogram, but the particular one here, we have these two triangles that are congruent, which basically helps me determine some key components of this quadrilateral. Since these two triangles are congruent, that automatically follows that this side is going to be congruent to that side. Okay? Since they are congruent, this angle corresponds to that angle. And if you look at this quadrilateral, these are alternate interior angles. So if you have a quadrilateral where alternate interior angles of a transversal that's going through two lines, if they are congruent, it follows that these two sides are parallel. Okay? So let's write down a theorem that we're going to be using to guide our problem solving process. And the theorem is for proving parallelograms. Proving parallelograms. One of them is that if a quadrilateral has one set, just one is sufficient, okay? Has one set of opposite sides that are parallel and congruent, then guess what? Then the quadrilateral is a parallelogram. Okay? So that's how far we can go in this particular problem, because we don't know anything about these two sides right here. Okay, so let's see if we can prove that this is a parallelogram based on what we have. Okay? So since triangle ABE is congruent to triangle CDF, so that tells us that corresponding parts of the congruent triangles corresponding parts of a congruent triangle are congruent. So corresponding sides CD and AB are congruent. So CD is equal to AB. Okay? And what else can we say? Angle DCA and BAC are corresponding angles, so they're going to be congruent too. So angle DCA is going to be congruent to angle BAC since they're corresponding angles. Alright, so now we can mark these angles right here and mark these two sides as congruent. But how do we know that they're parallel? Well, we can state that since angle DCA is congruent to angle BAC, that follows that alternate interior angles, these two form alternate interior angles. Alternate interior angles are what? Are congruent, which implies that these two sides containing these alternate interior angles are parallel. So it follows that CD is parallel to AB. Okay? So since we have a pair of opposite sides that are CD equals AB congruent, and CD is parallel to AB, since they're congruent and parallel, what does that help us conclude? We can easily conclude that quadrilateral AB CD is a parallelogram. Okay, so based on the information given, we can conclude that we can prove that this quadrilateral is a parallelogram. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation or any geometry concepts in general, just place it in the comment section below and we will be more than glad to support you. Don't forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on Mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.